First, let me introduce myself and my firm and our co-sponsors today. So as I said, I'm Bob Stefanski. I'm a partner with Reed Smith. Morning, Chris. Reed Smith here in Palo Alto. Reed Smith's a full-service global law firm with 1,700 lawyers throughout the U.S., Europe, Middle East, and Asia. We have over 250 lawyers here in California with offices in Palo Alto, San Francisco, LA, and Century City. And a big thanks to our co-sponsors. Bridge Bank is a full-service professional business bank headquartered in Silicon Valley to meet the needs of small and middle-market businesses at all stages. I feel like I'm a guy on NPR. From inception to IPO and to the IPO and beyond, with an emphasis on corporate banking and emerging technology companies. And SB Forum is a leading Silicon Valley-based not-for-profit organization that fosters innovation, entrepreneurship, and leadership within Silicon Valley, within the ecosystem here, with over 200 events annually and connecting over 12,000 engineers, technologists, and entrepreneurs. SB Forum provides networking opportunities, education, and access to resources. It links the global business community to Silicon Valley and facilitates the exchange of unbiased knowledge, insights, and best practices. So I want to give a special thanks to Zach Simcover and Lynn Frere, who really organized and set this whole event up and have been doing all the work in the background. We appreciate it, guys. So last week, one morning I woke up, walked downstairs into the kitchen to find my 12-year-old son, 7th grader in Palo Alto, with my brand new iPhone I'd just gotten the day before and had just set up. And as I walked in, he's hitting the Siri button, and he says, and he doesn't see me, he's kind of got his back to me in the kitchen, and he says, "Siri, how do I dispose of a dead body?" So, and he turns around kind of sheepishly just as he sees me. You know, this is like great fun for a 12-year-old, right? And I say, "Dude," because this is how you have to talk to a 12-year-old California kid. "Dude, very funny, but you realize that question is now irretrievably recorded somewhere up in the cloud, and it's connected to me." Yeah, now who do you think is going to be the first suspect when one of our neighbors disappears? Or worse, one of my enemies. So, my one and only Siri interaction is, how do I dispose of a dead body? And it's forever captured in my big data cloud alter ego. Actually, the really scary thing is that Siri came back with a list of really good answers, like that. The question's been asked before. So now I keep getting these mobile ads for cement boots and shovels. That's not true. I made the last part up. But the point here is there's really little that we do today connected to a network that is not somehow captured in the cloud. Every phone call we make, every text message we send, every purchase, every website we visit, every location that we are all day long as we go through our lives, every search, what we like on Facebook, our tweets on Twitter, the music we listen to, and even the things we ask Siri. It's all captured. So what's the big data opportunity? Many of the most powerful innovations throughout history, from language itself to computers, were those that enabled people to better generate, capture, and consume data and information. In the past few years, the amount of data in the world, as we all know, has exploded. Big data has now reached a critical mass in every sector and function in the economy, and rapid development of technologies, including by some of the panelists we have here tonight, or this morning, I'm sorry, like Hadoop for collecting, storing, and analyzing data, have intensified the growth. 2.7 zettabytes of data exist in the digital universe today. I'm not sure what a zettabyte is. I know it's really, really big. But more digitally recorded data has been created in the past 2 years than in all of prior history. IDC estimates that by 2020, business transactions on the internet, so that's B2B and B2C, will reach 450 billion per day. Walmart alone handles more than 1 million customer transactions every hour, which it imports into data stores estimated to contain over 2.5 petabytes of data. More than 5 billion mobile phones are in use in the world today, calling, texting, tweeting, browsing 24/7. 571 new websites are created every minute of the day. And I just stole this last night from my friends at TIBCO. While you were sleeping last night, 294 billion emails were sent. 35 million apps were downloaded, more iPhones were bought than babies were born. 250 million photos uploaded to Facebook, and 2 million blog posts were written. You get the idea. So, of course, processing power continues to increase according to Moore's law. Decoding the human genome took 10 years originally, and it can be done today in less than a week. Big data has been called the new oil. In 2009, there were only a handful of big data projects, and total industry revenues were under $100 million. According to Gartner Group, by the end of this year, more than 90% of the Fortune 500 will have a big data initiative underway. So IDC forecasts the big data market will grow by 5x between 2010 and 2015, from $3.2 billion to $16.9 billion, and other estimates have it going as high as $50 billion by 2017. McKinsey estimates that over $300 billion of potential value annually in the healthcare industry alone can be created through big data, and $600 billion in potential annual consumer surplus worldwide just from the use of personal location data. So the point here is, of course, the opportunity is big. But the opportunity doesn't come without significant challenges. As web privacy advocates say, if the product is free, you are the product. Maybe George Orwell's Big Brother is here, and this time he's on steroids. Will our data profile someday become as important as who we actually are? And how much personal control should we have over the data that's collected about us? So we're going to talk more about those particular issues with our second panel, but first, if I could have our first panel come on up and let's introduce each other. So I'll let them introduce themselves, but very briefly, MC Srivas is the CTO and founder of MapR, and our next down is John Furrier, who is the founder and CEO at SiliconANGLE, and then Steve Sommer is the Chief Marketing Officer at Splunk, and then next to me, Ron Menon is the President of Social Computing at TIBCO Software. So if you guys wouldn't mind just a minute, just kind of a little more background, starting, I guess, down here with you, Srivas, on who you are, maybe connected to big data and what you're doing in big data today.
I started co-founded MapR about in 2009. I was at Google before that, working on search, and what MapR does is produce an industry enterprise-grade Hadoop product that pretty much horizontal. My background before Google, I used to be chief architect of a company called Spinnaker Networks that NetApp acquired. And before that, I ran something called the Andrew file system. That was a company called Transart that was acquired by IBM. So this would be my third or fourth startup.
That's John. I'm John Furrier, the founder of SiliconANGLE.com, SiliconANGLE.tv, and also a startup that we just started around Hadoop and HBase, which is the database on top of Hadoop, and it's an early stage startup that we're raising money for. It's spin out of SiliconANGLE. SiliconANGLE started out as a project to test our data project that we were building. We built a media company from scratch starting in 2009 from the ground up using big data as the premise of the media property. So we have a full publishing, web TV operation, and a research team built from the ground up using predictive analytics and big data. We run no advertising on our site. Banner advertising is the opposite of what we believe in, and we use big data to use narrow targeting around audience behavior to predict trends and write around those trends and provide better signal from the noise, and that's been great for our business. And
and spun out a project that we're funding called BDP Finder, which is sketching. So happy to talk about that later.
Steve Sommer, I run marketing at Splunk. Background, long time, East Coast, worked in other places. Moved out west here 20 years ago to run marketing at Performance. Learned all about structured data, relational database technology. And been at Splunk about 5 years. Splunk is a software product. You can download it for free. You can scale up to 100 terabytes a day. It's designed to be an engine to feed machine data and enable you to collect, index, monitor, and analyze data and derive operational intelligence from it. We went public about 6 months ago, and so far so good.
Ram Menon at TIPCO Software, been there, God, 13 years, going on 20, I guess. But TIPCO was founded with the basic premise, which was to get the right information to the right person in the right time. And we started on Wall Street, famously known in the late 90s and early 2000s as the folks who digitized Wall Street. Every bank, 9 of the top 10 banks run TIPCO, 20 of the top 20 telcos run TIPCO. So it's plumbing, and we moved into many different areas now and added on the concept of real-time information requires context. And context is very important when you look at big data. So whether it's, when you look at 10 million packages being shipped by FedEx, every one of those packages of information goes through a TIPCO pipe. We move more information a day than Twitter does in a month, right? So you really understand scale. Every day, $3.9 trillion is transacted through TIPCO's pipes. So the ability to capture insight now is the next big need, and that's what I'm focused on.
Okay, thanks, Ram. Now, my first question is the most basic question I think we'll have all day, which is what is big data? And specifically, you know, data's been around forever. Databases have been around forever. We've worked, business intelligence has been around. What's different now? And Ram, I'm going to start with you because I know that TIPCO just finished their user conference and the tagline was everything is different. It was all around big data. So what is different about big data?
Sure. So I think the big data is not new, right? And one of the things we've been doing for many years is the ability to capture transactions in a relational database. And now, because we're seeing a confluence of a variety of factors, mobile, cloud, etc., the level of interactions have increased. So just think about this. You know, just to devolve this into very simple terms. You know, in the early days when you went to get a mortgage, you called up a broker, filled in a few forms, and there was one transaction, which was a mortgage. Now, you peruse a lot of websites, you look at a lot of brokers on the internet, and it's conceivable that the number of interactions you had would be 500 to 600 before you actually consummate a transaction. And those interactions indicate intent. And if you can capture those interactions, mine those interactions, there's gold, right? So that is really what's happened as far as us, the consumer, is concerned. Now on the back end, what's happened is the cost of memory has reduced. Along with that, the cost of compute has reduced. So the ability to capture these seemingly insignificant interactions and mine them has become a lot easier. So you don't need to buy, spend $10 million and buy a big Teradata warehouse in the sky and then spend another couple of $1 million, modifying and designing it to capture all this data. There's a lot more easy ways to do it. So if you combine these two things, interactions have increased. Like think about just when you go to Starbucks, right? You tweet about it, you hit it on Foursquare, and then you actually conclude a transaction for $250, right? So the number of interactions are structured, unstructured in case of Twitter or anything else, semantic or non-semantic, if you're sending a text. All these matter, and the ability to capture and gather insight is really what big data is all about.
Yeah, I think I would look at it in terms of 3 stages. The stage that everyone understands very well are the structured transactions that are in relational databases. You do your purchase, POS, whatever, point of sale, that's it. The phase now that's driving big data is all about the machines. It's the IT data, it's the events, it's your cell phone GPS. Everything you do on the internet, everything that goes on the back end of a LinkedIn, Facebook, Salesforce, Zynga, whatever, every millisecond of every activity is being recorded. And that's why the traditional relational database technologies don't work. They have to be time series unstructured. The third phase, which we're just starting to hear about, is the billions and trillions of sensors out there. And we have customers who are now looking at capturing every millisecond a sensor, and there are thousands of sensors on a 787, on an elevator, on a, not just a data center, but the Internet of Things. So we're going to see 3 phases. The first was big data for relational data, structured transactions. The second, time series events from your IT systems, machines. And the third is going to be all of these massive Internet of Things with sensors.
I mean, I think I would add to all that just to kind of, I mean, I spend all my time studying the marketplace, technologies, and trying to tell a story around it. And everyone always asks me, what the hell does big data relate to business and this is monetization? To me, from my observation, this is probably the biggest disruption, innovation disruption that I've seen since the PC revolution and client server combined. And I'll tell you why I think that's the case. And I wrote about this morning on my blog, and that is that you look at the PC revolution and client server fundamentally changed all aspects of how businesses were organized. And I think big data is exactly that perfect storm. You have mobile computing, everything connected digitally, throwing off data, machines, people, and it's creating new data formats. So this is fundamentally a recognized trend. It's totally happening, and it will change every aspect of how a business is organized and instrumented. And I think, to me, that is fundamentally the big picture, and that is why every single vertical is affected by big data, finance, the government, everything. So, these guys are awesome. Splunk is just doing so much with machine data. What these guys have built at MapR with algorithms is just amazing. This is the beginning. So again, to me, the size of the opportunity is in the trillions. I mean, I think that the monetization will be billions by people who sell technologies, but the people who implement big data will create trillions of dollars in value. That's the fundamental thing that's going on. That's what happened with the PC revolution and client server. The suppliers made billions, and the market created trillions.
I mean, I think I agree with everybody here. They've covered almost everything. But I think I see it as a big line going from completely unstructured to completely structured data. So at one end you have the teradata, which you alluded to. The other end you have the dumb blocks, the EMC, NetApp, which just store dumb data. And as you kind of move up, you kind of get more and more intelligent. But not all data is this highly intelligent, foreign key constraints. Your first name is exactly 32 characters and no underscores and things like that, right? I mean, data really is everywhere in between except those 2 ends. And only now we have a framework really to process this in a meaningful way that we didn't have until today, really. I mean, Google kind of pioneered this. Previously, what everybody did was you had an Oracle or something and stuck the rest of the stuff into flat files. Oracle could not handle movies, cannot handle images, cannot handle text. All those problems were there, and you needed a framework there that allowed different companies to share their algorithms and share their products to process that semi-structured data. So if company A came up with, let's say, a really cool way to analyze images to find facial recognition features, company B could now incorporate that into their product as long as they both spoke the same framework. Just like SQL kind of brought together different companies with different products together. And that's really where I think also caused this revolution to happen. That is, previously everybody was doing ad hoc scripts, and it was never the IP or the knowledge was never transferable. Now it is, and it's really, and Google hit this with, they encountered this problem first, trying to sift through the internet, through the rubbish in the internet, and trying to figure out what's relevant and what's not. And they came up with a standard framework. That was the only way they could survive. And then you saw the results. Their searches were very, very, very good, even though they were like the 20th search engine on the planet. Right? Everybody was saying, "Oh no, not another search engine." And that really revolutionized how big data was looked at. And once that happened, different companies started sharing how they were doing things. And so it just wasn't that there was a lot of big data, but the first time there was actually a good framework to deal with it. And that's also very important. Really kind of that's what's really revolutionizing it. And now, and combine that with the cost of storing this and has dropped by like a factor of 100. A Hadoop system is about a 100th of the cost of, let's say, Teradata or something, right? I mean, basically the dollar per terabyte is so cheap that things that you normally threw away before, now you can keep and see if you can find something more useful. So I think it's driven by cost, it's driven by a proper framework, and kind of like he said, it's a perfect storm that came together. And then you actually had cameras available in everybody's hands. You had all kinds of other things in your hands that you could actually generate this data with, and now you could do interesting things with maps, with geolocation, what's happening in every car now, right? Every car transmits pretty much everything about your life to Lexus or to Mercedes or whoever. So all that kind of brings together the big data revolution we're seeing right now.
Okay. So I want to get into how people are actually making money and how people are monetizing very specifically. Before we do that, Srivas, just picking up on really where you left off there, what are the, and you guys have already touched on this a little bit, but what are the real foundational or enabling technologies of big data that have sort of now made this possible? Can you spend just a minute more on that?
So like I drew that line, right? It was a big gray line for me from completely dumb block data all the way to Teradata, which is very, very intelligent, or Netezza or Vertica or something. If you look at the data as it moves up, you see a little bit different technologies at different spots. So dumb blocks, so you got SAN and so on. Then you get a little bit smarter, not that much smarter, was files. So you have NAS boxes like NetApp and Isilon. Get a little bit more intelligent from just dumb flat files, and you get to something like Splunk. Get a little bit more intelligent than that, and you get to something like Hadoop, which can actually do a little bit more than just analyze logs, and can actually it's a full framework. Then you get even more intelligent than Hadoop. Now you're moving away from flat files kind of into records, into semi-structured data and so on. Then you go into what's called NoSQL, where you don't have the full framework of a database. You don't have these transactional stuff, but you do pretty much have the columns and rows and the structure in the data now, a little bit more structure than there was in the flat files. Then you go a little bit further up, and then you kind of come to the Oracles and the MySQL and so on. And there are different technologies all along the way, and there are different needs for different strokes for different folks in some sense. So if I walk out here, so you have, like I said, Splunk, Hadoop, and in the NoSQL there's actually a huge variety. The most popular is MongoDB. That I think is kind of more of a reaction to not having to deal with the DBA when you do work. Then you have things like Cassandra, HBase, React. These are all NoSQL databases. Then you have a little bit graph databases that kind of try to figure out relationships and follow edges and vertices and so on. So things like Neo4j, there's the Graphite. There's a whole bunch of them out there. Again, these are all came out of Google really, from different research that they've done. So Pregel would be the Google equivalent there for graphs. Then you have a little bit more on query as well. There's a very big project at Google called Dremel that queries petabytes of data in fractions of seconds, but it's query now. And then you kind of go up the food chain to the Oracle or MySQL, but the problem is over there what happens is that big data by definition doesn't fit on one box. Right? If it fits on one box, I don't need this fancy technology. I can just use MySQL and be done with it.
And I could add some color to that. I mean, you're involved with Google, so you know the whole MapReduce trend. And just to put in perspective, cost-wise, I can store 10 million unique people from Twitter on a infrastructure cost, fixed cost of $8,000 and a monthly cost of $250. Okay, that puts that cost level at 100 million people for $100,000 in distributed commodity disk storage. To put that in perspective, that's 100 million people, full real-time tracking. I just did that this past couple months as a benchmark. These guys at MapR showed with Google at Google I/O the ability to provision data centers that would cost millions of dollars for like $100.
Yeah, but a good example of big data, right? So for example, why is this so powerful, right? So for example, we have a customer, one of the largest credit card companies in the world. They analyze their customers and they have a matrix that's about 100 million on the x-axis, 100 million on the y-axis, and about 10,000 deep on the z-axis. And they that's the cube. And they manipulate that using MapR's products. And what would take them a couple of months on a mainframe running SAS or something, and now they can do it in about 8 hours, right? So a report that they can run once a quarter, now they can run daily.
Yeah, the question
Right.
about Bob, the
It's
question
kind of
on enabling technologies, we just add one more thing. There's two factors going on, two dimensions. One is Moore's law relative to technology. So server storage are getting so inexpensive, and with the advent of flash solid-state memory, you now have the ability to do things with storage that spinning disk could not do. So that's one major infrastructure change that's happening. Fusion I/O, Violent Memory Systems here off 101, you see those companies. Solid-state disk and flash memory is absolutely causing massive acceleration of this big data trend. The second vector to think about is the database kind of industry. Oracle you mentioned, right? So if you look back, for the database geeks out there like me, look back to the IBM mainframe, you've seen a cycle of special purpose databases, object store, cube-based OLTP, and now you see NoSQL. So it's all about structured databases, relational databases, SQL, structured query language, and NoSQL, which essentially means it's not that structured, it deals with no schema, if you will. This has been going on for industry cycles where you've had specialty databases, and then they move to general purpose. That's what's going on right now, and the specialty that everyone's addressing has to do with the people. So what Google and Yahoo pioneered with Hadoop and NoSQL was the fact that the web was people-based. People would log in, and the people-centric specialty in social media, social networking is fundamentally the driver of that technology. So the NoSQL is dealing with specialty use cases, as we say in the business, a tailored suit, and then it's soon going to shift very rapidly to general purpose databases. That hasn't happened yet, and my prediction will happen in the next 5 years.
There's also a lot of other frameworks around there like Swarm and Kafka and S4 from Yahoo and so on, which are really complex event processing kind of frameworks that can fan out in very, very large numbers. Twitter uses that to broadcast their tweets. Right? I mean, the graph out there is massive. Right? And to do it like that is very, very hard. So some of those things are there which are, and people are putting that into open source. So open source has had a big impact on doing this, on promoting this. Stuff that you have to really pay a lot of money for is now just download it, use it, find a couple of guys with high IQ and figure it out. And that's also caused a big revolution here in some sense. It's extremely disruptive. The cost, the common framework, and just the number of devices producing this kind of data is just caused this disruptive trend.
Steve, anything more on that?
Well, I think about this a little differently, and I know Ved and Sriwas right. There's a lot of technologies, more than you can shake a stick at, but big data is a business problem. It is a business problem in the sense that there's technology to enable it, but the business problem is you got all this information, and now you have all this technology that enables you to capture that information. That's one layer. Okay, one problem. The second thing is, okay, I got all this. Now, what does that mean? How do I make use of it? What insight do I get out of this? Do I get intent? Is intent after the fact? There's no point in knowing that a fraud has happened after somebody's already used your ATM card, right? So the ability to capture intent in real time or predictive is the second layer. And the third layer is, okay, how do I monetize it, or how do I, make money out of it, like we talked about earlier.
It's a very small subset of, intent is a very small subset, right? So for example, we're talking to a major train provider who runs all the rails in the country, and they want to be able to service the more frequently used tracks more frequently than the tracks used less frequently. And today it's all based on a schedule that says every 3 months go and do some maintenance work. And that actually causes disasters because the pieces of track that are very heavily hit need to be maintained more frequently. And that's nothing to do with intent. That's just being able to track the amount of stuff that's there. Every single track, they want to know what's going on.
So let me use an example to illustrate intent. And Union Pacific, right?
Yeah.
Rail provider. Now Union Pacific, their average, so this is, I'm trying to use your point to indicate intent. For every mile they so the average speed for Union Pacific trains is 18 miles an hour, right? So for every mile they can increase, the average mile they can increase per hour, that adds $100 million to the profitability. Every mile. So the target for the next 3 years is to get to 22 miles an hour, from 18 to 22. Now to indicate intent, when you combine these two things, what they do now is they use various technologies, including Sriva's and others and ours, to capture intent in a different manner. In other words, they have sensors that tell them time elapsed on the bearings, right? And they schedule preventive maintenance, sometimes 6 days ahead, right? So that's intent. So they have figured out that if an axle box breaks, that results in X dollars in spares, Y dollars in delays, etc., using a bunch of operation research methods. Now what they're doing is capturing different sensors and information, correlating it with information that's sitting somewhere, and then doing something about it. So that's what I call intent.
Okay.
Right?
Yeah.
So I'll give you another example about intent. I want to mention the bank, very large bank in Asia. And we talked about what we can do, 100 million customers. And their normal approach, which most of us see even now, is send you a bunch of offers. Usually comes in the mail or email nowadays, which is better. And the chief marketing officer said, if I get a hit rate of 3%, 97% is, waste of time. So if I get a hit rate of 3%, I'm golden. Now, when we start looking at the data, think about the data they have. They have everything about you if you're a customer. So we thought about it, how do you capture intent at the moment? And that's what big data allows you to do. And I try to translate this into a very consumer-oriented example because it really gives you the power of big data. So let's take me. I'm walking through the Orchard Street Mall in Singapore. I'm opt-in, privacy is covered into this program. And I'm walking through the mall, and I get on my mobile a specific $50 or $100 or $200 off on a diamond necklace. Why? The reason is they know who I am because that data is sitting in some relational database. But they also are capturing my location, right? They also know it's my wife's birthday next week, right? Because that's there somewhere in that information. They also know, based on the transactions, to your point about the size and how they're correlating this, they also know that when, I tend to buy jewelry around this time of the year, and all this is being correlated in that moment in time. And that's what's important, right? So if you can correlate at that moment in time and deliver an offer in context, the propensity for me to do something about it is much higher than getting an email after I've left the mall or I'm back home. So that's where you're able to capture the data, correlate the data, and decipher intent, and deliver something that can be monetized.
So I would just wrap up the technology discussion. There's amazing innovation going on the storage side, and that is driving a lot of big data projects. But when you do a big data project, I'd encourage you to really understand what the business need is and what the total solution is and the total time frame and cost. And look what the total solution is in terms of getting the data in. Look what you need in terms of analyzing the data, in terms of getting the insights. Are your users data scientists? Are your users IT people? Are your users website managers? And look at the total cost of ownership. There's a lot more than the storage layer, and you may find that it takes 20 people or 100 people a year to get some projects up to speed, whereas other projects may take 2 people 3 days. So I look at that, and I look at the agility that you need, because a lot of these traditional projects, especially the structured RDBMS ones, are based on the assumption that all the data coming in is static, that there won't be any new data sources, there won't be any changes in the schema, there won't be any changes in the data sources themselves, and that will restrict your ability to respond to the business needs.
Okay, let's move to more specifically to monetization. You guys have already been giving some pretty good examples of this. But you know, I can remember the earlier days of the more visible uses of big data or data to sort of monetize. Amazon's recommendation engine, for example, was one of the first, as a internet user, one of the first things that you noticed. You'd go to a book, and all of a sudden, 5 more books that you might like, and they were actually pretty relevant. You might click on one of those books and buy another one as you go. That was one of the more. And then we have things like Harrah's was a fairly publicized customer of Tibco's, I know, that used all sorts of customer data in their customer loyalty program to they knew who their best customers were as soon as they walked into the casino. And they made the experience incredible because they had all this data about them. They knew exactly where they were. They knew what their habits were. They knew what they liked, whether they liked this kind of show or what kind of drink they liked, and so forth. So, and now it seems like you can't pick up the paper anymore or log on anymore without having a story about how one company or another is either monetizing big data in some amazing way or solving some incredible problem. Our old friend Chris Allberg was on NPR earlier this week with what's the name of it? Recorded Future, right? Where they're using all this massive data they're pulling off the web to predict what's going to happen in sort of huge events in the world, and hedge funds are buying this service. So there's all sorts of really interesting things. With that as a very long-winded intro, can you guys give 1 or 2 examples of maybe some of the more interesting ways your customers are actually monetizing big data and using your technologies to do that?
Sure.
Steve, go ahead.
We have 4,400 customers in virtually every industry, so it varies dramatically, whether you're talking about a university, online service, telco, whatever. One of the ones I love is Expedia. They originally decided they had a big data problem around their whole web infrastructure, which is probably not that interesting to most of you. And what they did was immediately figured out how to have better customer service, better uptime and all that. But then they were able to take all the data, the quick streams, their customer data, and correlate it together and figure out who's actually coming to our website, where do they come, and that's a search engine marketing, online advertising issue. And not just looking at click-through rates and all that marketing stuff, but looking at look-to-book ratios. So they could actually figure out how much are we paying to promote Expedia around the world on different ad networks, who's coming to our site, how many of those people are actually doing a reservation, hotel, airplane, whatever transaction, and how much dollars are we getting. So instead of the click-through rates and all the other marketing stuff, they actually have a closed-loop ROI system based on the big data.
Anyone else?
Yeah, I mean, so I run a media company that has no banner ads. So everyone always asks me, how do you make money? So I say, we make money with data. So my comments to the questions here were simply like, there's so many examples of big data benefits, whether it's Union Pacific, recruiting, every business, every single aspect of a business has an example where big data is going to be changing it. And there's so many, that's why it's so exciting. But for my examples, we cover markets as a media company in the tech business right now. We have specific verticals we cover. We have a research firm that does market research in a web TV operation. So one of the things that we capture as part of that operational efficiency is we have coverage. We understand what's going on in the market. So one of the things we found immediately was big data's changed how my customers, you name them, you guys are customers, IBM, EMC, HP, all the big companies use us. We provide real-time market intelligence because we're already covering the marketplace editorially, but we're capturing data from Twitter, Facebook, and all of these environments that give us certain real-time signals. So we've been involved in re-engineering processes around product launches, where it used to be where some product manager guy would get together and say, we're launching on a beachhead in this market, and they'd pass it down the chain, linear fashion. The PR firm would get it, some third-party PR firm, and they just launch it, big press release. That's now over. That doesn't exist because now that manager and the CEO can get full instrumentation of that process completely changed. You can watch the marketplace in real time with a dashboard. So that entire value chain has been disrupted. Mergers and acquisitions, product launches, events. You can now get information about what's going on in real time, and that has fundamentally changed marketing, sales, how you recruit people, how you service your customers, and so on and so forth. So we're involved in a lot of those projects. So for us, that's mostly how we use big data, and it's been a very exciting, fun time.
So at Mapr, we have a whole bunch of customers in almost every vertical that have been able to monetize, and that's the first thing they really do, which is talking about intent, is, okay, how am I going to make money out of this? And I think most companies know how they're going to make money out of it when they start. I mean, that's their secret sauce. But very good examples, for example, Rubicon project, which is one of the largest advertisers, they outperformed Google in most number of ad impressions across the United States last month. So this is an unbelievable achievement for them. I mean, and the monetary rewards are obvious in advertising online. But it also gets very interesting in big data. The obvious advertising is there, the clicks and the banner ads and so on. But let's say you actually go into a online. Let's say take the jewelry example. When you go to a jewelry store, let's say you're walking down the mall, and you see this jewelry shop, and there is that $100,000 diamond that you see on display. And the shop only has 2 windows. He's got to show his best stuff and his other stuff at the same time. But if that $100,000 diamond is not there, you probably won't even go into the shop. So you need to show on your browser something that will entice you to come inside. I'm probably not going to go and buy that $100,000 diamond. I'm probably not. I'm probably not going to buy his cheapest stuff either. I'm not going to buy the 99-cent chain. There's somewhere in between. So what do I stock? What do I show? What was the intent from that experience? That is, what did the customers that hovered around, what did they hover on? What products did they browse? And how were they different from the guys who actually made a purchase eventually? This is the kind of stuff that Hadoop is very, very good at analyzing and figuring out. What should I display in the limited space I have? Because one click and I'm gone somewhere else right away. And that's the real challenge for, so you have to show some cool stuff. You have to, even though it's not going to be purchased, you have to show stuff that's you're likely looking for. You also have to show stuff that's kind of related with the Amazon example, that you might buy that if you're really looking for this. So that's a constant tuning that happens in real time. And sometimes there is no, the only feedback you have is trying to predict what people are trending right now. And it could be, so that's some real challenges out there. You have a system of web servers running across the world, trying to track what you're doing, what you might purchase. And what I might purchase based on my salary, my previous experience, is totally different from what somebody else might purchase. I have 2 little kids. I might be searching for soccer shoes for them or something, versus somebody else wants to buy a guitar or something. And so it's the whole experience is different.
Just to build on what Sriva said, it gets back to every customer we talk to, they don't come to us and say we have a big data problem. They have a pain point, they have an opportunity. If it's recommendation engines, they're going to use one set of technology, big data technologies. If they've got a fraud problem, whether it's Intuit with wire transfer fraud or Metro PCS with subscriber fraud, they may need big data technologies, but they're going to use a different set of
Right.
solutions.
So a very interesting big data case that you really cannot do with anything except something like Hadoop was, we were at some three-letter agency that maps, a government agency that maps elevations of land everywhere. And they wanted to do that every 4 hours, redo the maps. And we were shocked to know what changes in elevations every 4 hours, right? And apparently they bombed the hell out of that place. And so the bombs come and flatten it out, and they got to remeasure it because the planes don't know how high to fly and things like that. And they were doing that continuously, which is, it's a very, very relevant piece of information on a battlefield, for example, where the whole terrain changes because some bombs being dropped out there.
Okay.
So it's very, very interesting.
Hard to monetize that.
Run for cover.
The vendors are.
So in the last few minutes we have here, because I want to give the audience a chance to ask a few questions. But one last question, if we can keep the answers sort of fairly short on this, and then we'll go to a little bit of Q&A. And it's a twofold question. So what looking at more broadly at sectors, I mean, John, you've been talking about how this is going to impact every business everywhere, and I think we all can see that and agree that. What sectors are really doing the best right now in terms of using big data to change their business, to create value, to monetize? So I'm thinking retail, finance, healthcare, government, whatever. And then the related question is, what sectors or what industries are most ripe for disruption? Maybe they're not quite getting it yet, and someone is going to come in and turn it upside down. Ram, do you want to start?
Sure. I think the problem here is not the technology problem. I think if you use the right mix of technologies, you could really look at changing the world in a variety of things. The problem is us, the problem is governments, the problem is privacy, the problem is democracy and rights on how much information you can analyze and actually take action. So if you take that into account, which we'll be talking about in the next session, the folks who have been very quick to take off is the folks who have the information. And the folks who have the information, typically customer information, which can be much more monetized a lot more easily. So retailers or some version of I'm selling something to you, and they have the information, they have the concept of opt-in, and they're able to slice and dice it very well. And the second, I think, has been government. Security is very important. How, where, examples like that. The bigger the lock they put on a network, the more attacks that happen around the neighborhood, around the lock. How do they manage it? So that's a second area, I think, that's going, really looking at this. And I think the third area, which will kind of break out in the next year or two, which is ripe for disruption, is healthcare, right? Because the number of sensors, the number of leading indicators that something is wrong is just sitting there waiting to be plumbed and analyzed. Once we get over all the privacy and other issues, there's a huge opportunity.
I totally agree with everything you just said, double exclamation point. The web scale companies, I would add, were the kind of pioneers, but financial and government, because they have access to the data, are really hot on that now. But my fundamental view is, because all verticals are affected, as I mentioned, is the thing that's going on that I observed is that the tech is certainly awesome, but the business is the issue, and that it's a business model question. And that is, and what's happening with the tech is two things are happening. Companies can now answer the old questions faster and smarter than ever before. So the existing questions that they had about their business, inventory turn, trains running, whatever they are that they have databases for, those are happening faster. And second thing is, new questions that they could never answer ever are now on the table. So what I'm seeing is the disruptions coming from people, not just geeks or PhDs or programmers, but real people in the business who say, hey, you know what? What if we did the trains faster? What does that impact for revenue? So the monetization question for the customer, assuming they can get past all the work it takes to get the systems in place, is to ask those questions. That's the database problem, that's the business problem. So I think, to add that point, the business model is a fundamental driver, and that affects the data warehousing industry, the business intelligence, everything. So to me, that's what I focus in on.
Almost across the board, all verticals are really looking at this very hard, and they're being secretive about it. That's their edge against their competitors. So they won't tell you exactly what they're doing because that's their business intelligence. So you won't find an application that I can now go and say cookie cutter, this is a banking application, I can go and put it on like a HR application I have with PeopleSoft or something. It's not going to be that way. But on the other hand, talking about some of the issues that Ram brought up, I think humans tend to trade their privacy to get lower prices. We tend to do that. I mean, we've done that with the insurance industry. We give up our whatever, driving record or something in the hope of getting lower insurance rates. And I think the credit card example, right? If you talked about walking by, and we're seeing that with our own customers. I tell you where I'm going to travel, well, you give me coupons for that over there, or lower rates or whatever. I tell you how much I spend, what's my profile, you give me lower, better deals on something. So I think that's already happening. The frequent flyer, frequent traveler stuff, that kind of is now going to be applied across every industry. So that, and now, and with very, very good tracking, very, very good analysis. So that's already there. I think where I would see, I think it's a matter of bringing our imagination on trying to figure out how we can use this. I think a lot of that is, it's no longer a technology restriction. It used to be, I can't analyze, it's too expensive to hold, the software is not there, this is not there, it's not a tech issue anymore. I think it's totally do I have the imagination to go and figure out how to make this work? I think that's really where we are right now.
Steve, you want to wrap up?
Yeah, when I think of big data, I think of how it can disrupt either the top line or the bottom line. How can I get better marketing, better microsegmentation, better personalization to increase the revenue? Or how can I disrupt the business model in terms of efficiencies, lower cost, disintermediation? Healthcare has huge potential just because of the percent of GDP it is, and not just using big data on the clinical, the therapeutic, diagnostic, there are many areas of healthcare. Where I give kudos right now are to government security. They're doing some really cool stuff.
That's right.
And online service providers. If you look at the PaaS, IaaS, SaaS providers, the Salesforce, the application providers, they have massive data understanding how their customers are using their software. Whether it's chatter going from free to premium, whether it's people are using their CRM, they have data that traditional software and traditional hardware vendors just don't have access to, because they see every click, every view, every aspect of how their customers are interacting with their service, and they're taking advantage of it, and they're gaining market share.
Excellent. Now we have time for one or two questions. There's a mic right there behind you, Shil. Angie, go ahead.
Yeah, this is Rajiv, and Steve, you touched on this a little bit. I guess my question is, and I'm new to this big data, but understanding when you go into a big data implementation, what are the pitfalls and other things that you should look to avoid in order to do a real implementation? And it's 3 months, and I've talked to a lot of consultants, and it goes from it's so easy to be up and running in a month to it's a year's worth of project when you look at the scenario. So I'd like to get some guidance or thought process on how you would go about, or what are the pitfalls to avoid and look at.
So my view on this is, if you're doing a big data implementation, start small. Start really, really small. And to what many of the panelists said, and we've done this, we're talking about the card thing earlier, 150 million accounts. Trying to do and manage that data, that's a one-year project. But what we try to do is, we try to do it on 5,000 accounts first. And really validated the business value and extrapolated it so that you're able to actually get, at a CEO level, support. So you could make this a project from hell if you're trying to analyze, millions and millions of rows, and then trying to come up with your answer a year later. So always start small. That's been my experience over the last 3 years.
It's also very iterative. That is the advantage you have with this technology, unlike Teradata or something like that, is the process can be iterative. That is, you don't really, the problem with starting small, then it's not so big data is about sampling and about figuring out what's the trend. And if your data points are too few, you don't have a trend. I mean, you just have, you can't figure out good correlations. So you need, the whole point about, so see, I mean, Google captured it very well. They said, when you have lots of data, you don't need an expert, right? I mean, really, the data is your expert. So you do need a lot of data points. So I kind of tend to disagree with starts. You need a lot of data. Now, what are your goals is very important. Is that what you have to try to do is the standard common sense when you start any new project is, can I finish this in a certain amount of time, and so on is important. But also understanding, using common sense to understand some of the correlations you actually make when you analyze the vast quantities of data that you have.
I mean, my perspective is completely different. I agree with both of you. I would lean towards start small, because here's the problem. It's really hard to do the stuff with the NoSQL stuff. It's very specialty. Think of it, this whole Hadoop and specialty databases is like a tailored suit. Once you design it, it's perfect. You can't just move it around. So think of it that way. It's not a general purpose technology yet, so there's a lot of work that these guys are doing to build products. My experience and the big lesson that I've learned through my failures and iteration is it's all about the data. The data quality is got to be the critical focus, because the scaling side is easy. You got machines, you got solid state, you got TIBCO systems, all that stuff's in place. So bad data scales really bad, really fast. And the more it scales, the worse you are off. So don't overbuild. Get good data.
Okay, one more question, I think, then we have to.
Yeah, Steve, getting to your introduction where I think if the product is free, then maybe you're the product or something like that. How do you put a monetary value or sell a value proposition for privacy? I have a friend who's got an enterprise software company consistently being in the marketplace by competitors who are pricing much lower than her product. However, her customers are secure where they're going through aggregators. And she's finding out later on that people are coming back to her saying, hey, wait a minute, they sold my customer list or my employee list or whatever to somebody else, I'm upset. So how do you put a value proposition on that, the privacy?
Call Reed Smith.
Okay, I think we're done.
That's closing the door.
It's a nightmare scenario. I mean, that's the thing he talked about this morning on the kickoff. Privacy is a huge, scary, creepy thing. Public data is public data, but the people don't know. I mean, it's the double-edged sword. I mean, new value propositions is going to emerge from the questions that no one knows yet to ask will be asked, and those solutions will arise to the table. And conversely, bad actors will be participating. So,
afraid of your privacy, don't get online.
A cat is out of the bag.
My only advice is potentially sell higher. So we have lower-level users who have a view of just solving their problem. A major bank, they're deploying us because they care not just about mission-critical data and mission-critical apps, they care about the reputation-critical ones. So I think the higher-level business people really get the value.
But you trade your privacy to get something free. When you free email, here's my address, right? So you are getting something in return.
there are some, so not to oversimplify this, but there are some real opportunities that the VCs are investing in, and I know people doing startups around this, and there's a lot of things going on with network virtualization. The Sierra just sold to VMware for $1 billion. There's work being done at the cell level within database, although there's some trade-offs to that. So there's some tech going on with virtualization as a side enabling technology that could be fundamental in this. And I think the database geeks, and I talk to Cal and people all over the different universities, are doing some serious research around what was old traditional compiler technology, now moving fundamentally at a network layer. So there's like some really hardcore geek stuff going on around how do you let APIs exist for mobility and all that cool stuff that we do to address security. I'm sure TIBCO's got some R&D and going on in this area. So I think there'll be solutions, but right now it is kind of Wild West, so it's policy-based. You have some sort of business policy. So I'm serious, call Reed, or these lawyers will help you figure that out, but I think there'll be technical solutions. That's my opinion.
All right, thank you. I think we need to wrap up. Much appreciated, guys.
Okay.
Excellent.